This is number 40 on the 4.1 homework. The question's asking the graph y is equal to r of x, which is equal to x to the fourth minus 5x squared plus 4. Wants to use a sign analysis and knowledge of n behavior to sketch the graph of the given polynomial. Let's look at what we know. I know that I can factor this and make this x squared minus 4 and x squared minus 1, and both of those can factor. So this becomes x plus 2, x minus 2, x plus 1, x minus 1. Since this was a degree of 4, I knew there were at most 4 real roots. And as we can see from the factors, we actually have negative 2, 2, negative 1, and 1 as our 4 real roots. We actually have exactly 4 real roots. I also know that there are at most 3 turning points. I know that is a graph with a positive coefficient and an even degree, that it's going to do something like this, coming in from the quadrant 2 and going out in quadrant 1. So keeping that in mind, let's sketch a graph. You could say a sine graph of our roots. We've got negative 2, negative 1, 1, and 2. If I test negative 3 in these factors, I get a negative number, a negative number, a negative number, and a negative number. 4 negatives makes a positive. Since this graph does not have any double roots, we can safely assume that this is going to alternate, plus, minus. Maybe I'll test 0 just to be sure. I have plus, minus, plus, and minus. That's also a positive. Okay, so yes, it is alternating, minus and plus. Now that I have that, let's sketch a more formal graph. Still a sketch though, so I'm going to go with negative 1, negative 2, 1, and 2. And what the plus means is I want to make it positive. I want to make that part of the graph positive. So we're going to come in from up here, cross there, cross here, cross there, and cross there again, keeping our 4 x-intercepts here. So we'll do a quick check. We have 1, 2, 3 turning points. That's what we should have had. And this is a very good sketch of the n behavior, and this is the n behavior of the graph. The 3 turning points, this, and this, and our 4 roots, 1, 2, 3, 4.